All right, so we have, let's go back to the pen. So with the components we have discussed so far, one is this CPU section, which is this box, right? Okay. Then we have these IOs, and for each IO mean I stands for input, O stands for output. Okay, so we have for all these IOs we have a control block, and then we transmit the data on an actual physical port. Okay, third component is this memory. I should have used another color. Okay, three components so far. There is a fourth component that we need. Okay, let me go down and draw it here. So you can see that if you have these many, I mean, in the real system there will be so many other input outputs too. If those are active, if they have system associated with them and they constantly provide inputs or interrupts to these CPUs, and what they keep doing is when this needs some data, the CPU control block where we have, they go and okay, they tell the CPU you work on that one. When another signal comes here, interrupt comes here, you need to provide service to those. And when you provide service, you make do processing, you make decisions, and the actions you take on different IOs. So your CPUs are very busy when the system is running and processing, and they're busy on servicing all these IOs. Now if you use this control intelligence system in a particular application, like you're doing it, for example, if this system is used more for image processing things, okay, or maybe this system is used for some networking applications on routers, gateways. So in that case, that certain processing will be done more. Okay, for example, if it's an image processing or video processing, that we need to have a lot of processing on video done, and that is very computational intensive. What you don't want to do is your CPUs will be servicing different IOs. If you have to process a lot of video data or image data, then you better have some help to these CPUs, some sort of hardware, a block that is much better on processing that dedicated um, service or dedicated application, or this hardware we can call, okay, let's start down here. Okay, let's pick blue for this. So this block, which we call it's dedicated, or we can say that okay, it will accelerate certain applications. What happens is this block, and the example we were talking about, the image processing or video processing, this block, for example, will always be busy. The inputs will come. Again, its need is on some sort of control logic. So this is like hardware. The inputs come video. This just processes that, and what these CPUs do is um, they take the data from here. They give the data to that our accelerator, and once that accelerator finishes, then CPUs can write back into the memory that we have up on the picture, or they can take the data from the memory and take it out. So we don't have all these CPUs busy doing just video or image processing. So that's a big help to CPUs. So this is also called like offloading your CPUs.